Okay, let's look at how we can check our answers to inequalities.
When you solve an equation, you substitute your answer into the original equation to check your work. When you solve an inequality, it is equally important to check your answer. However, inequalities often have an infinite number of solutions, so it's impossible to check each one. Suppose you solve the inequality s minus 4 and 1/2 is greater than or equal to 2 and 1/2, and get the solution s is greater than or equal to 7. The number line shows the inequality s is greater than or equal to 7. To check that s is greater than or equal to 7 is correct, first check that 7 is the solution of the related equation. Then check the direction of the inequality symbol.
Okay, there's basically two things we need to check. When we say s is greater than or equal to 7, we're saying two things. We're saying s can be greater than 7, and we're saying s can be equal to 7. So when they first tell us to check the solution to the related equation, they're talking about let's check that part that they're saying is equal to 7. So first we check, is it true that if s was equal to 7, this inequality would be true? And then we can check to see, is it true when this is greater than 7, is this inequality true? Because then we know that it will be true that s is greater than or equal to 7.
Step 1. Check the related equation. First, write the related equation. Then substitute 7 for s in the related equation. Simplify. 2 and 1/2 equals 2 and 1/2. So the related equation checks.
Okay, so we know that it is true that the value of s can be equal to 7. So now let's check to see if the value of s can be greater than 7 as well. So we'll just try a value that's greater than 7 and see if it works. There are lots of values to choose from.
Step 2. Check that the direction of the inequality s is greater than or equal to 7 is correct. To do this, choose a number that is greater than 7 and substitute it in the original inequality. Substitute 10 for s in the original inequality. Simplify. 5 and 1/2 is greater than 2 and 1/2, so the inequality is in the right direction. Since both steps of the check are true, s is greater than or equal to 7 is the solution of the inequality s minus 4 and 1/2 is greater than or equal to 2 and 1/2.
And again, we had to check two things because we had a statement that was saying it's greater than or it's equal to 7. So we had to check both. All right, let's try a couple. An airline restricts checked baggage to 80 pounds per person. You pack one 42-pound bag. How much can your second bag weigh? Write and solve an inequality. Check your answer. Okay, so we can think about the words of this first. You're obviously bringing two bags with you. So, bag one's weight and bag two's weight. Now, what has to be true about these bags' weight? It says that it's restricted to 80 pounds per person. So that means that the weight of my bags has to be no more than 80 pounds. It can only be less than 80 pounds, or it could be exactly 80 pounds, but it can't go over. So bag one's weight and bag two's weight must be less than or equal to 80 pounds total. Okay, so bag one's weight we know, 42, and bag two's weight. These two weights are going to be combined. So we're adding We don't know the weight of bag 2. So that's our unknown. Maybe we could use B for the bag. Must be less than or equal to, that's this symbol, 80 pounds total. So we have an inequality that we can solve. Now we're supposed to solve it. Always whenever we solve inequalities, we'll also graph them and then we can check our answer. Okay, so I think I'm going to do that work over here. 42 plus B less than or equal to 80. So I can subtract 42 from both sides. And I can see that the weight of my second bag must be less than or equal to 38 pounds. Okay, so I can graph that. Just kind of sketch out a number line. I do need to graph 38 and maybe some of the numbers around it. Even if you want to go by 2s or something, you can. But I'm just going by 1s. So it's less than or equal to 38. So it can be equal to 38. So I'm going to use a filled in dot. But then it would be less than. So this graph represents my answer. The graph is nice because it's giving us a visual of the possibilities. We can see that the bag can weigh 36 pounds, 37 pounds, 38, anything less than 38 or equal to 38. Okay, now we can also check our answer. Now we have to check if it can be less than 38 and we have to check if it can be equal to 38 because there's basically 2 parts to our answer. So let's check 38 first. Let's check. 42 was the weight of our first bag, plus if our other bag was 38, would that be less than or equal to a total of 80? Well, 42 plus 38 is 80, and 80 is less than or equal to 80. They're equal, and so it works. We also should check the less than part. We check the equal part. If it's equal to 38, it works. Let's check the less than part. So choose a value less than 38. One of these shaded values. Like, let's try 36. If the first bag's 42 and the next bag is 36, will that be less than or equal to 80? Well, 42 plus 36, that's 78. And yeah, that is less than or equal to 80. So the less than part of our statement also checks. So it is true that the weight of the second bag can be less than or equal to 38 pounds. All right, last one. A number minus 3 2/5 is more than 17. Okay, write and solve an inequality. Check your answer. A number. This is unknown. Minus means to subtract. 3 2/5 is more than, that's the symbol, 17. Okay, so we have our inequality, and to solve it, we would need to add to both sides, inverse operations, like we've always done for equations. And we can see that n is greater than 20 2/5. Right, to graph that, we could sketch a number line. 20 2/5. So maybe I'll include 20, and I'm going to break each section down into fifths by dividing each section into 5 parts. So there's 1 part, 2 parts, 3 parts, 4 parts, 5 parts. Okay, so when I look at this, I have 1, 2, 3, 4, 5 little spaces between each whole number. So now I can easily mark my fraction. 20 2/5. 20 2/5 would be right here. Well, I need to use an open dot because it's not equal to 20 2/5, but it's just got to be greater than 20 2/5. And then I would shade greater. Okay, so on this one, we really only have one thing to check. We don't need to check if it can be equal to 20 and 2/5 because our symbol indicates that it cannot. We only need to check to make sure if things can be greater than 20 and 2/5 and our equation would, or our inequality would be true. So I'll try like 21. It's a part of our shaded area. So let's check. 21 minus 3 and 2/5. Will that be greater than 17? Well, 21 minus 3 would be 18. Take away 2/5, that's 17 and 3/5, which is greater than 17. So our solution checks. All right, I think that's it. See you next time.